So today we're going to go over SQL. I learned enough to break everything. Basically going over some pitfalls and other things that, as a developer, you may or may not consider when writing for your applications. So a little bit about myself. I started writing web applications a very long time ago. I actually started with Cold Fusion 2.0. Just a quick show of hands, anybody ever used Cold Fusion 2.0? Yeah, there's only a couple of us left. And I commiserate with you. It was rough, it was dark times back then. I'm on the content board for Learn CF in a Week with Dan and Carl, who are here. And we just revamped that system entirely. So, and I like taking long walks on the beach, kicking people in the head, definitely not in that order. I am actually a second degree black belt in Taekwondo, as well as my son is a third degree. My whole family is black belts. My daughter and my wife as well. My son's actually a world champion. I'm a multi-state and district champion in Taekwondo. So it's my my passionate hobby outside of writing code. So to speak about Learn CF in a Week really quick, for those of you who haven't seen it, it's a really great resource if you want to start learning Cold Fusion or want to brush up on some skills. It was recently revamped completely. Redid the entire system, modern UI. We redid all the samples to script versus tag-based code, and we moved the entire content to GitHub so that now the community can participate in the content versus just us working on it. And there's a public Q&A or QA for asking questions about it. We're currently working on the revamping the hands-on section, which should be done shortly. So it's a really great resource. So, who are all of you? First question. And unfortunately, my slide doesn't see the answers, so I have to look. There's nobody's watching YouTube, that's good.
I just quit.
Appreciate that. Thank you, sir. So most of us are here to learn something, that's good. We're all hopefully here to learn something. Maybe I'll learn something too, never know. So, a little bit more about who you are. So how much SQL experience do you have? Yep. That is what I would have completely expected.
You might want to give the URL for those people that are just coming in.
Oh, that's going to be complicated. I can't rewind it, unfortunately. So yeah, most of us use Google. I do as well. I have a couple SQL books, but I actually use them to hold up my monitor, literally. Don't use my monitor. So one last question. So what SQL server do you use? That's about what I expected as well. I'll be going over variants of some of the stuff I'm going to talk about for the top 3 on that list. I don't have anything that goes over anything for PostgreDB2. I don't use those ever. I've never used those ever. So really not well versed to speak about those. So wake up. Now there's something. Since we're all here to learn something, what we're going to kind of go over is how SQL Server really handles the SQL statement you give it. How to kind of speed up some of that basic CRUD work you're doing, some information about indexes, a lot of statistics that matter that you really probably never looked at or cared about to look at, and some example of where somebody wrote some really good SQL that they thought was really good SQL that didn't really go as they intended. So, really, why are we all here? Because one day in your programming life, you wrote that. And you thought it was the greatest thing you wrote. Greatest thing since Betty White. For those that don't get the joke, I know jokes aren't really funny when you explain them, but Betty White was actually born before you could buy bread sliced. So I know the joke is greatest thing since sliced bread, but Betty White is actually older. But when you get down to it, you just want the DBA to stop making you look bad. But you're probably thinking they're the same. We both write SQL. Basic SQL statements, DBA writes them, we write them. That may be true, but they just know a whole lot more than we do. And that's where they kind of differ from the rest of us. They probably read all these books. Most of us in this room have probably never looked at any of these books. But let's say you did. That takes a lot of time. That's why they're a DBA. Some of these books are really hard. Like the funny one I think of is Learn SQL in 10 minutes takes actually 4.5 hours to read. So your mileage may vary. That's without going through the lessons. If you actually go through the lessons, it takes considerably longer. But the name of that book is important because it breaks it down into 10-minute segments. But if you take the book as a whole, it's a pretty long read. But like everybody said, you go to Google, right, to find all your answers? I don't know if I trust Google either. This I actually found on the internet, no joke, on Stack Overflow. A response to a SQL question was downvoted 19 times and it was the approved answer. So, buyer beware. Everything you find on the internet may not be true. I know we kind of think it is most of the time. But, as our good buddy Thomas Jefferson said, the possession of facts is knowledge, the use of them is wisdom. So it doesn't matter how much you know if you don't use it the right way, you kind of hurt yourself. So, let's take a look at how to get some of that data you're getting to a little bit quicker. So the first thing when you write a query statement and send it to the SQL server, it's going to create an execution plan. It's going to create one for every degree of parallelism for your query, basically how many times you can split it up and run it on different data, on different processors. And it's used by the database to optimize the path to get to your data. It creates one for every SQL statement coming through, whether you want it to or not. There's different ways you can view those execution plans or query plans. In Microsoft SQL Server, Management Studio ships with a visual tool. Oracle uses explain for prior to running the query, and it'll give you a text-based output of what it is. And MySQL, you can use MySQL Workbench to get the query plan as well. So what those look like? So here's what the query plan looks like in SQL Server. Really, really complicated, but very useful. MySQL Workbench kind of looks the same way, and then you got Oracle. Oracle's all text-based output, so it's a little bit harder to discern, but if you're using Oracle, you're kind of using that output. So what does the query plan actually tell you? It tells you the path it got to the data, kind of like a Java stack trace. We're all familiar with those. Its index usage, on what indexes it used along the way, and whether or not it actually used them. The cost of each section that it hit throughout the query plan, as well as the percentage of that piece. And it'll actually give you suggestions on how to make it better. How to make your query better, what missing indexes are there, what indexes possibly need to be redone, other little tidbits of info along the way that it thinks could help this query go a little better. And it'll give you a whole bunch of other statistical info that you probably don't care about, like percentages down to 0.00 something and farther of the overall cost. But while these execution plans are great, databases kind of store them a little separately. MySQL and Oracle use a shared cache to store the query plans. I'm sorry, Microsoft SQL and Oracle use a shared cache where MySQL doesn't cache the query plans at all. It caches the queries themselves, not the query plans. But you may run into instances where your query plan just keep getting flushed out of cache and you're not being actually used. That can happen when it's forced via code. You can actually write SQL to force the query plan out to create a new one. If you're running out of memory, so what's called memory pressure, you can run out of actually storage for them, so it'll start getting pushed out. If you're running alter statements on your tables, it can cause any query plans that are using that table to wipe. So any new queries coming through will have to create a new plan. And if you have up-to-date statistics on SQL Server, so anytime statistics are updated on a table, any query plan using that table will automatically dump out of cache. And I'll have to create a new one. And in some big systems where you've got a lot of throughput, a lot of queries, the database's effectiveness and efficiency is based on whether or not that cache is in use. So if you're flushing things out of the cache, it can have a detrimental effect on the speed of even a basic query. So how can we utilize that cache a little better? A, just get more RAM, honestly. Probably the biggest thing you can do, make sure your database has a lot of RAM. And, which I've actually seen, make sure your database is configured to use the RAM that's there. I've seen many databases that have 64 gigs of RAM, but they're configured to use 16 gigs. So you've got all that RAM just sitting there doing nothing. I'm sorry?
Microsoft's defaults to 2 petabytes of RAM.
Yeah.
And it will use all of it that it can.
Yep. So it's important to use what you've got. Use query plans, which we'll go over a little later. Use stored procedures that are appropriate for your database where possible. That helps a lot of the redoing of query plans. It'll kind of keep those. And you can just use less queries. That's really generally not an option. Now, execution plans are really great. They help your database perform better. They help it get to the data better. However, there's the downside. The database will create a query plan for this query that this query will not use. Makes sense, right? Makes total sense. The reason being is these queries, according to the query optimizer, are not the same. They look the same, they are not the same. The variant is the ID. They're using a different ID. So since it's a hard-coded ID, there are 2 different queries, they will get their own query plan. Now let's say you've got 10,000 IDs in this table, and you don't query plan that ID, you're creating 10,000 query plans. One for each hard-coded ID. So use query params. They kind of solve that. So now when you have a query and you pass a query param, it comes through as a question mark, as an example. So all the queries look the same regardless of ID. So no matter if you run this one time or 1,000,000 times, the same query plan will be used every single time. Definitely reduces your cache overall volume as well as speeds up because you don't have to create query plans every single time. However, there are times when all these fun query plans that make your data, getting your data even quicker, can cause less than expected results. For example, if your data structure changes a lot, let's say you run an alter statement on a table. Any query plan using that table will be flushed, like I said before. If your data volume in a table is growing really fast, like it's a log table, you're pushing a ton of data into it, odds are the statistics are going to get out of date, things in the indexes are going to need to be updated. So the query plans will very quickly become obsolete, and the database is going to have to keep creating new ones to keep up with the data volume. And the other one is if your data has a high degree of cardinality. Anybody know what cardinality is? Got to have a whole slide on it. So cardinality deals with the uniqueness of your data. So a column with high cardinality means a lot of the values are unique. Let's say a username column or an email column. Lots of unique values. Low cardinality is like a status column where it's like the values are like 1, 2, 3. So a table with high cardinality requires a lot of indexing and a little different handling versus a low cardinality column. So when you've got a lot of data in your tables, there are some different ways you want to handle getting that data out. The first is never use select star. Ever, 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 ever. I'll go over why in a little while, but select star is really, really bad. Except when you're developing, obviously as we're writing something brand new, we're going to select star and get all the columns back and figure out what we need. But once you know what columns you're going to use from that query in your application, reduce that down to only the columns you want. Don't pull back 50 columns if you only need 2 of them. It's a lot of extra work. If you need to page through data, let's say you're pulling back 10,000 rows, you're never going to display 10,000 rows in a browser. That's just crazy. So page it somehow. Either page it through the database by pulling only certain records, or pull the query back, cache it, and then page it that way. But try and page the data some way. Don't try and load all that into the browser. Optimize indexes to speed up where clauses. We'll go over that a little later. Avoid using triggers when you're doing large volume inserts. If you're doing a bulk insert of 1,000 rows or more or less, depending on your database volume, disable the indexes before you do a big blast insert and then turn them back on inside a transaction so you don't mess up data, because every single trigger is going to slow everything down. So you kind of want to disable those if possible. And reduce any post-query processing. If you're dealing with large volumes of data, anything you get back from the server, try and have the database do as much as it can before you get it. So, for example, don't pull back 1,000 rows of like first and last name. Then if your application concatenate those into a full name, let the database do it. It's faster at it. It's cleaner, it's easier, and it's less work your application has to do when cycling through 1,000 rows. So let's say you're inserting and updating large data sets. Reduce the calls to your database by combining queries. I'll give you an example of that in a second. If you have any bulk loading features of your database, use those instead of your application to load mass data. It's a lot faster. And if your database supports it, use XML or JSON to load data in your database really quickly. It actually speeds up a lot of things when you can just bulk load one big packet of data and then have the database process it, versus trying to process it ahead of time and feed it little by little. So, query combining. Some ways to get the data faster. So here's an example of how to bulk load 2,000 rows of data. So what we're doing here is we have a query with a loop around it, looping the query 2,000 times to insert 2,000 rows. We've probably done this 1,000 times. However, there's a better way to do it. Do it that way. The variant is, instead of looping the query as a whole, we're looping over what is going to be inserted and making one giant SQL statement. Instead of 2,000 SQL statements, it's one SQL statement with a 2,000 rows to insert. Doesn't seem that big until you actually time it. So on a test environment I had, the first one ran at about 800 milliseconds, about a second. The other one ran at 45 milliseconds. And that was local. Big variant. And it doesn't really, that number for 2,000 and 45 milliseconds doesn't climb that much if you go to like 4,000. It's only maybe 10 milliseconds more. It's really, really small. So you can load massive amounts of data in a small amount of time, and it frees up a whole lot of resources. However, it seems like everything I'm giving you has a bad side to it. So when you're doing query combining, there's some things that can go wrong. If you're inserting 2,000 rows, and one of those rows is not liked by the database, it'll blow up the whole batch. So you won't insert any of them. So be wary. You could overflow the query string size that's allowed by your database. So you may want, if you're inserting tens of thousands, you may have to look through and only insert a couple thousand or 5,000 at a time. So watch out for that. You could lock up your database because you're blasting data in at a high rate. You could end up with some database locks, which should clear because this method is really, really fast, but it could cause some database locking. And it's really kind of hard to get any usable results out of the load unless you go back and query the database again. So I would only use this method if you don't care about the result, you just know that it worked. Unless you want to inspect anything, I wouldn't use this. There's other ways to load it, but it's really good at getting a lot of data in really quickly. But sometimes faster is just straight faster. And that kid's my new spirit animal. The biggest thing about doing this is your network traffic is massively reduced to a single run versus multiple network calls over a database. They are processed by a single batch by your database, which makes your database actually handle it way faster. Your database likes it when it can do one big thing versus a bunch of little things. And the processing time, like I showed you in the example, is generally considerably faster by far. So now we've got the data in. Let's take a look at how we can utilize some indexes to get all that data we just blasted in out a little bit easier. So let's take a look at the indexes. So we've got some index types. So you have a unique index, which is the primary key of your table. Every table should have a primary key, whether you want or ever going to use it or not. Always put a primary key. You have a cluster index or an IoT for Oracle, which is an index organized table in Oracle. It's basically an index that maps exactly the way the data is stored. And SQL Server can only have one. Other databases can have more, but SQL Server can only have one. A non-clustered index, it contains pointers back to the actual data, but it stores it its own way. And it's a little slower than a cluster because it contains pointers, not the actual data in the right order. So, what should you index? So, do index data where 10 to 50% of the data is usually returned. So, if you got a table of 1,000 rows and you're generally returning a couple hundred of those, you want to index a lot of that data. Columns where the where clauses have high cardinality, like you want to index your username column, you want to index your email column. Those are you want to index those. So it will make your lookups way faster. So what don't you want to index? Small tables, under 100 rows. Database will never use the index even to create it. It'll hit the table first. Any table with columns with low cardinality, like status columns, you don't want to index those. The database will never use those. And with low cardinality, any table will only a couple values. So if you have a Boolean column, don't index it. Your database will never use it. They'll just skip it. It takes more time to use the index than it would the actual table itself. So when your database goes to use the index, there's a couple ways it will use it. One is an index scan or a table scan. That's where it basically touches all the rows in the table, every single row. So if you're looking at a query plan and it's doing a full index scan or a table scan, that's generally bad because it's hitting every single row looking for data. And it's only useful if you have a little bit of data. You have an index seek, which is really what you want, is where it's only touching the rows that qualify for what you're looking for, and it's really, really good for large data sets. And even no matter what you do, you set everything up right, you did it all right, the query optimizer may just say, I don't care what you've done, I'm going to do my own thing anyway, which is really, really frustrating. When you've got a query that is running really slow and you've done everything the optimizer says to try and make it faster, and the query plan, the optimizer still says, I'm going to do my own thing, I don't care about your index, I don't care about this, I don't care about that, starts throwing all that good stuff you put in away. It'll do that often, unfortunately. And it's really hard to debug those weird scenarios. So you're probably asking, do I need an index? Depends. And honestly, if you look up on the internet, do I need an index for my table? You will get the exact same answer. It depends. It all depends on the data you're looking at, the data you're getting, different aspects of your data. To tell somebody your table always needs an index is an incorrect answer. It all depends on what you're doing. So let's look at a couple of the fun little stats and figures and other things that the database, that DBAs don't want to share with you. This is how they keep their jobs. So there's some performance impacts to your servers and your database. We're going to take a look at those, like memory load, memory pressure, hard drives, and network. So for example, processor. When you're setting up a SQL server, make sure your SQL server has CPU priority. I'm banking that they probably don't right now. This is something you have to go set up, and most people don't do it. If you give SQL Server CPU priority, it means it will be the number one thing to use the CPU when it starts overloading, and everything else will be put in line behind it. Otherwise, your database is running considerably faster. So then, any normal server operation won't be impacted by your database. Your database is going to win in every scenario where it comes to using the processor. Watch for other processes spiking your CPU that have nothing to do with your database. A lot of times on a Windows machine, there'll be other services running on your database server that generally you don't even need. They're just there because they're Windows. And Windows likes to install a bunch of stuff you never need. So look for spikes that are eating up your processor, and more often than not, you may just kill those sort of processes out and stop whatever services those are that are running that you don't really need. Make sure that you have enough cores in your database to handle your load. You want to try and keep the average processor load on your database at 50% or lower. The reason for that is you want to give your database room to spike without spiking to 100%. So if you get hit with a big load, all of a sudden, you don't want your database to go 100% and stay there and plateau for a while and then come back down. You want it to be able to spike up to 70, 80, 90%, but never max out. Because if it maxes out, it can't do anything else. Even OS operations can't be performed because the database is eating everything. You want overhead. You want to leave some overhead. So if your general current state of your database is sitting at 75% normal utilization, you'll have no room to spike if you hit a load. So you want to put more cores in there to make sure you can bring that overall load down so that you have all that room to spike when it comes to it. So memory and RAM. Get more. RAM's cheap. RAM's probably the cheapest thing you can ever do to update a database server. Just throw as much as throw in as much as your database can handle, and as much as your server can handle, and make sure that your server is using it. You want to prevent paging out to the hard drives. So you keep loading it with RAM until it doesn't page as much. It's still going to page a little bit, but you want to try and reduce the amount of paging it is to the swap files or any other hard drives. So you do that by just adding RAM. Tons of RAM. And, like I said before, make sure your database is actually using it. Like I said, I've seen many occasions where you put a ton of RAM in and it's not used. Make sure you're using it. Some databases can be configured to use the RAM for cache versus a hard drive. So if you can do that, configure it that way, it'll speed up your databases tremendously. And look for other processes like that were spiking your processor. Look for other processes eating your RAM. There are sometimes other processes out there that are just running and eating up RAM. Find out what they're doing and try and stop them from doing it. Because they're taking valuable resources away from the database. So hard drives. That's something nobody ever considers for a database. But hard drives are really, really important. It's generally the only moving part of a server. So it's going to be the slowest piece in the chain. If you can, use solid state. Solid state back in the day, it wasn't good for servers. Now it's probably the best thing you can do for a server. Everything will run considerably faster if it's on a solid state drive. No spinning disk, none of that. It runs considerably faster. Make sure you don't run out of database space for your server. And I speak from experience on this. You will never know the pain of when your database takes itself offline because your log files ate up all your drive space. And you can't turn your database back on because it has no room. And you have to do all these fun, weird, fancy tricks to turn your database down, clear the log, restart it, hope it'll come back up. I kid you not, one time when I worked at a previous company, we were on the phone with Microsoft for roughly 16 hours to get a database back up. Because we ran out of drive space on our production server. And it was an older version of SQL, and there was no way to purge the log when the database was offline. So it was loads of fun. So make sure you don't run out. The trick to that for your log files is, by default, if I recall, SQL Server, their log files are set to allow for unlimited growth. Don't do that. Cap them. Worst case, your database will throw errors that ran out of log space, but your database is still running and you'll clean that out. Versus if you allow unlimited growth and you don't keep an eye on it, you'll run out of drive space. And then everything will go haywire. This one's kind of important. Don't store your log files on the same physical drive as your database, especially if you're not using solid state. If you're using solid state, this isn't as important, but if you're using spinning drives, keep them separate. Because they do different things. So if your log files are in a constant state of write, your database is more in a constant state of read. So drives can only do one thing at a time. So if you're trying to write logs and read data simultaneously, something's going to give. One thing's going to get slowed down, so you want to try to avoid that. So use SSDs for 10 TB if you can. Preferably use your whole database on solid state. And when it comes to configuration of your hard drives, you can actually do this. Most people don't, but you can. Configure your log hard drives and put them in a write priority mode. That means write operations take precedence, so they will write data faster than they will read it. And alternatively, your data drives should be in read priority mode. More often than not, your database, you're pulling data from it versus pushing to it. So you'll be able to pull data out quicker because the hard drives are geared towards the operation of pull things off. So it'll do those operations first. So if you have your database set to your database drive set to read and your log drive set to write, things will actually speed up pretty considerably. But this only is relative if you're using spinning disk, if you're using solid state, doesn't matter. Yeah.
Are those like BIOS config settings? Or
Yes.
are those, okay.
Yeah, it's actually in either BIOS or somewhere on your hard drive settings. It's not part of this database server, SQL server, or any database server at all. It's more OS level or below. So network stuff, stuff you never probably learned, didn't know about. This really only matters if your database and SQL server, or your SQL server and your app server aren't on the same server. They should not be. They should be separate. You don't want one eating the other. So do your best to minimize the network hops between the two. They should be one hop to a single router and then back. The more hops you have, the slower things get. So you want to reduce those hops as best you can. Watch for network spikes that actually will hurt your data retrieval between the two machines. So if you're only getting the data back you need from the database, that will definitely speed up network traffic. And if you can, this is one key point, if you can, put dual NICs in your servers and have your SQL traffic isolated to a second NIC, network card. You can configure that in multiple machines, multiple ways, but it allows that traffic to be isolated so that if somebody wants to download a large file from your server, retrieving data from your database isn't affected. Those two operations stay separate. You're keeping everything separate in its own little world. And like I said, if the clients are loading a lot of data and everything's not segregated outright, all that data retrieval from a user could actually impact data retrieval from the database. So you kind of want to separate all that as best you can. So there's some other ways you can actually speed things up. So use a secondary database for reporting. Don't use your primary database to do all your reporting if you can. More often than not, when users are doing reports, they don't need real-time data. More often than not, they're perfectly acceptable and you can talk to them. If, let's say your data is maybe an hour old, is that acceptable for reporting? In most cases it is. If it is, create a secondary server and have your database push data to it and use that secondary server for reporting. It'll make your web applications run considerably faster because reports are generally pretty heavy on your database. So if you have those in a separate operation, you can kind of speed up your application by offloading all that. Store static lookup data, stuff that never changes. Like countries, states, zip codes, data like that, local on the web server, and some other database. For example, SQLite, Redis, CouchMongo, something local. Because that data is never going to change. Unless this country gets another state or something else gets another, that data is really not going to change. So there's no reason to store it in your super powerful database that is static data. Keep that static data out of there, put it somewhere else. Cache as much app data that doesn't change on your web server as best you can. But make sure you have a way to flush it out in case something has to change. Some really fun, important statistics that you've probably never looked at. Most of this is relevant to any database server, but there is a Oracle exception, which I'll show you in a minute. So, recompiles for stored procedures. These generally shouldn't occur, but they're generally caused by memory pressure or something in the stored procedure causing it to recompile mid-run. They will generally compile as they're ran, but you should never see recompiles, which are actually the stored procedure is running, and ran is something that forces it to recompile itself and run again. Those are generally bad. There's this thing called a latch wait, which probably nobody in this room has ever heard of. It's a very low-level lock that databases do on data. They should be sub 10 milliseconds. If you are looking at your database statistics, which you can get this out in different ways in different databases, and you see a latch wait of over 100 milliseconds, your database is probably dying. It's that sensitive. Lock waits. That's the amount of time your database is waiting for locks to clear. That should be pretty slow. And full scans, you can get data on how often your database is doing full scans versus index scans. And the more full scans you're doing, that means it's not using the indexes it was given. We'll go over that in a second as to how that can occur. Now, some Oracle-specific data. There's table statistics you can get, column statistics, index statistics, and system statistics right out of the database itself. I don't use Oracle, so I can't give you examples of those, but that's some really Oracle-specific stuff for those of you using Oracle. Some other fun, important statistics. You have the cache hit ratio. How much you're actually using the cache that's there versus actually going back to the database itself on the disk. You want that number to be high. You want to hit the cache as much as you can, as often as you can. disk read-write times, how long it's taking to get data in and out of your database, sort of files, hard drives. You want those numbers to be low, best you can. SQL processor time, how much time it's actually eating up the SQL processor. You want those to obviously be lower, and how much memory is being utilized, and so on and so forth. So now that we've looked at all that, let's look at some good ideas of SQL that people have written, may or may not have been me, that were well intended but didn't work as somebody would think. So, what's wrong with this? Or pull out your phone again and you play audio participation. So yeah, the primary thing wrong with this is the select star. Now, select star itself isn't bad. You get all the columns from the table, right? Well, let's say you write something today, and your table has 4 columns, and you write a little thing like this that gets select star. And in this occurrence, you're going to get select star from both of these tables. That's how it's written. So you're getting select star from art and sales. Let's say down the road, somebody decides, you know what? We want to store an image of the art in the art table a year from now. Well, this query is still sitting there running, right? Now, let's say this query, you run it, and you get, maybe you take out that ID, and you get like a few rows coming back. Well, now they're storing a blob in your database of the actual image. Because this is select star, you're getting that blob back, whether you want it or not. So now you're overloading your data retrieval with a whole bunch of data that this query was never intended to use. So while great when you first wrote it, down the road it becomes very bad. So like I said, when you're developing, select star is perfect because you can get all the columns back, see what you're going to use. When you finalize what you've done, or you know what you're going to use, get rid of the star and actually put the column into DB. Otherwise, this down the road, they'll be trying to debug, why is my database dying? Why is my app server dying? It's just a simple query. And you go look and go, oh. I've seen this where somebody added a ton of columns to a table that were unused, so it does happen. So there's no poll for this one, but here's another example of a really, really, really bad query. This one I dumbed down to protect the innocent. But this is an inline query that just should not be. This query actually doesn't run. I took a whole bunch of it out just to give you an example of what some of the stuff was. But this query has a bunch of declares, selects, other things. The database server will never create a query plan for this. That is kept. It'll create a new one every single time it sees this because of how it's written. So if this is ran on a high volume page, and this is ran 1,000 times, you got 1,000 query plans. It'll never reuse them. And it'll have a hard time using any cache effectively for any of this. So this query is actually highly detrimental in your database. It doesn't bode well.
What will, when you actually run that as a CF query, what do you get? Is the last select statement wins, or how does that work?
It was, I can't really go into what it was, because I gutted a lot of it. But you get a lot of different things out of it. Yeah, there's different. Ultimately, you get the result of the last select.
Oh.
So it's just really bad. So what's wrong with this? Why is this wrong? I commend those that are honest and use the last and selected the bottom one. You wrote it last week. Transaction, not really that important. But the biggest gotcha is that's the wrong way to get the ID that was inserted. You will, unless you have a low volume or purely lucky, you won't get the ID you just inserted. It's two different queries. And if there's a trigger that was ran or another query that ran before yours, you're going to get the last. So scope identity is going in SQL Server will give you the last ID inserted. So if you did your insert, something else came through, did another insert, then you ran scope identity, you're going to get theirs. And if you're doing something specific that needs that ID that you just got back, you just broke your app. Because now you're linking somebody else's ID to whatever you were doing. So that's kind of the wrong way to do that. That scope identity could either be A, inside the query, as part of the insert, as a secondary part of it, which will get you back. Also, you could add a variable to the query itself, and Cold Fusion will actually give you back the ID that's inserted. So there's a couple different ways to handle that a little better. Now, here's the big one. What is wrong here? I'm going to give you a little bit of time to look at this one, because this one's a little complicated.
You forgot parent in the insert.
Come on, Smalls. So I'll walk you through what this is doing, and then you can kind of figure out what's going on. So we got a query that's getting some data. We're doing a file upload. We're manipulating the uploaded image. We're inserting, or updating the documents table, which is what we did, and we're writing a log. Pretty simple, basic sequence of events. But there's something catastrophically wrong with this, and what this will actually do is crash your server. And if you want to leave now, that's happening. Still has your server before you go. So those of you that said your database would get locked down, who wants to give me a reason why you think it's going to get locked down? Yeah.
If you've got a transaction that's holding open a process on the SQL Server, and in the middle of that you're running something at the app server that's heavy, like CF file, CF image, that transaction is going to wait until it gets all the way to the bottom of the last CF query statement and it closes. That whole time that SQL Server process is locked.
You are mostly right.
Okay.
Yes. So why this is wrong is, first off, we're creating a transaction with an isolation level of serializable. That is the most brutal isolation you can do. It will cause a low-key lock on any data retrieved. So if we look at the first query, we're selecting from documents where the document name is like that, and the ID is not 0. So any data that query returns is going to get low-level locked to prevent things that are the phantom data records, as well as prevent any dirty reads. So all those rows, potentially the entire table, will get locked. And that will sit there and wait for the following code to finish, which we now do a file upload, which is perfectly done next. We will resize the image, and then we will update. Now, the fun part is that update will probably get locked, and it will cause an internal deadlock on ourselves, because it can't update the data that's already been locked up. So this in itself is could cause a deadlock on itself. So very, very, very much bad. So, anybody know what a phantom read is? Yes, I know I mentioned that. So phantom read is, let's say we pulled that data and then somebody tried to insert a row that would have gone inside that data that I pulled. It's called a phantom data record, and creates a phantom read. So it's a data record that exists that doesn't read yet because it's held in stasis waiting for a lock to clear. What will eventually happen in this is that phantom data record will get tossed, because the data lock gets stuck. And then the phantom read, whatever was calling it, will time out. And that data record that was supposed to be inserted will just go away. So this in itself is really, really bad. The way to fix this is literally take out the transaction. You don't need it. It's really not necessary for this. And that's about the only fix you ever have to do to this. Just take the transaction away. And it'll still run. It'll actually run better. Yeah.
Or maybe wrap the last two queries in transaction if they have to be closely coupled.
You could, yeah. But ultimately, you shouldn't need this. If you ever have to do data locking, don't do it from the Cold Fusion side. Run store procedures that can lock data internally in the store procedure. Don't do it from the Cold Fusion side. Anybody know why? Yeah, I don't have a poll for this one, but I'll give you why. So when you lock data from the Cold Fusion side, you create a lock that is from Cold Fusion to your SQL server. Now let's say Cold Fusion itself crashes out. You still have an open data connection to your server, to your SQL server, that is maintaining a data lock. If Cold Fusion crashed, it never sends a kill signal to that database connection. So now you have an open database connection with no source, with no kill signal, holding on to database locks. So once you restart your app server, all those locks still exist. So any data trying to come through and reach that data that's locked is not going to get deadlocked or timed out or other weird things. So the only fix for that is to actually go into the database and start killing threads until you find out the offender that actually started your lock mess. Because if you go, like on SQL Server, you go to SP lock and you run it, and if you have more than, and if SP lock gives you more than a couple hundred responses, you've got a problem. A lot of times you will run that and you may see thousands of rows. That means something way back early started causing locks and everything started piling up. Then you need to run things like SP-who and SP-who2 to find out what's actually the blocker and kill that so everything else starts flowing through. Because you have to find the source, not what's currently blocked. If you start killing from the top down, you're never going to actually, everything's just going to be piling up. You got to trailer all the way down to the actual blocker and kill it, which is really hard to find sometimes. So, go forth and be your own hero. Hopefully you've learned something that will help you, because this kid is out there somewhere. Our buddy Little Johnny Drop Tables. He exists, as well as hackers and other nasty people that want to do bad things, or just users that don't know better, or bad code, or other things. Questions? Don't be shy.
Is there a performance benefit on store procedures as far as like execution plans and the rest? Or is it pretty much the same as it's a query to do it right?
So the question was, are there any performance benefits to store procedures versus inline queries would be? Depends, honestly. Depends on the complexity of the query you're running. If it's really complex, multiple joins, any declares, things like that, subqueries, things like that, then yeah. Store procedures do become beneficial because it'll compile it and leave it, and not recompile or create new query plans every time through. Usually a store procedure will create its own query plan, and it'll maintain that until it needs to clear it out. So anything really complex is really better to be done as a store procedure. Yeah?
This is probably a stupid question.
No stupid questions.
I always use CF lock when I'm inserting. What?
CF lock.
Yeah, for when I'm inserting into the database to get my max ID back. You just said don't use CF.
CF lock is not for database. That's for variable locking.
Okay, so.
Don't use CF lock on database transactions.
Okay.
It's not for that.
What is the preferred?
I wouldn't use any locking mechanisms from Cold Fusion to my database. I would let my database do it as store procedures if I had to.
Okay, so what command are you sending to say lock while I'm inserting so that I can then get the max ID for the
It all depends on your database, but in the example I showed, you could actually do as a secondary query to the one that was sent, just do a select scope identity, or actually Cold Fusion has a function in the query to get back the ID. I think you just name a variable. There's a variable on the query tag itself, and it will return you the metadata from the inserted, which will give you the ID you created. Yeah, so look at the attributes for CF query, and it'll be in there. Yeah.
Any performance benefits for using views rather than data query?
So the question is, any performance benefits for using views? Yes. They're not as good as a stored procedure, but they are better than an inline query statement because it's got a pre-prepared stored query plan that's attached to it. And just like a stored procedure, it will use it as often as it can until it can't use it anymore, and then it'll create a new one. But yeah, it's a little bit better than creating really weird, broad query inline. Yeah.
The benefit to index multiple columns.
Yeah, I think I missed that. There was a slide I had.
But sometimes they won't use it.
I think there's a slide I missed. Oops. Now I can't see it. So I don't know. Yeah, I can find it. So there it is. See, I missed this. Was it in here?
It was at the very bottom.
Was it?
Yeah, go back.
Not that bad.
Nope, not that back. Up there, up here.
There and there. Keep going. Yeah.
That one.
Covering. Yeah, I must have skipped it. So covering index. I totally skipped that. My apologies. So covering index. I totally missed covering index. A covering index is an index that contains columns in the order of your where clause. So if you're getting 3 different columns out of a query in your where clause, make sure you have a covering index that matches those columns in that order, and your database will use it. And more often than not, your query plan will use it very happily, and it'll make everything way faster. Because now it has all the data in the right sequence for indexing. It's super quick and super awesome.
Also, if your where clause is hitting 3 columns, and then you're also pulling back maybe 4 other columns in a repeat fashion, when you build that index, you can include those 4 additional columns. They'll get included in the index, and then it never has to hit the root table to get those data values back.
Correct.
Try to keep it in 4 or 5 columns.
Yeah, you don't want to have your covering index like 9, 10 columns. You want to kind of keep it a little small. Otherwise, it's spending more time rebuilding the index and actually using it. You got a question?
Yeah, your example that broke everything because of the transaction lock. Is there a potential downfall there for removing the transaction wrapper that could cause a problem theoretically?
Not for that example, no. Without should run better without transaction at all. Doesn't need it. More of a bad coding versus the transaction around it.
I kind of wrap everything in transaction, but I don't really understand what that would be.
Yeah, my rule of thumb is if you don't know what it does, don't do it. Because you're more often going to break something versus make it better. Yeah.
I've seen people try to avoid using select star by on application start querying for all the fields in the table and then storing it as an application variable and then calling that select in the select statement. But it's still calling all the fields. It's not. You might as well just have select star at that point.
Yeah, that doesn't seem like a good idea to me at all.
Okay. Because then, of course, the problem happens if you try to get rid of one of the fields, then you have to restart your application to keep all your pages from error.
Yep.
So it's just select star is something you should do until you are.
You should do in development, and once you're done with development,
okay.
replace it. Yeah.
With that, okay.
Do you use NODB versus SAM, or do you have a preference on this?
I don't really know. Whatever you choose to use. Any other questions? Yeah.
You're going to enable that last survey?
It should be. It's supposed to auto enable when I go to that slide. If not, I'm very sorry. I don't have a way to fix that. It worked in all my tests. It's why you don't use live stuff in a demo or in a slide.
It doesn't work because there's no node.
See, it caught me. My hope is always yes. Any other questions? I'm not sure how much time I have, so.
Are you gonna send out the link to your slide deck?
This is being video recorded. The slide deck in itself, by itself, out of context, may not make sense without me talking through it. So the video, I'm not sure what Billy's doing with all the videos you're recording. So we're gonna watch that eventually at some point. Any other questions? Well, I'll still be around if you have any you don't want to speak out loud. So thank you, everybody. Appreciate it.